Basically, titration is used to analyze the concentration of
Yes,
an
sir.
unknown solution. The concentration of an unknown solution. For example, we have an acid solution of known concentration. We have also alkali solution, but we don't know its concentration, right? We don't know either it is dilute or concentrated alkali or base, right? In other words, we don't know that how many number of moles are dissolved in 1 dm cube of solution, right? Similarly, we also know about the acid and we also know about the base. Let's take an example, a simplest example, that aqueous solution of HCl reacts with aqueous solution of base alkali to form NaCl and water, and this type of reaction is called as neutralization reaction, right? So we will be finding the unknown concentration of alkali solution using this equation, using this reaction with the help of an experiment called as titration. What we are going to do in order to find the concentration of unknown basic solution, unknown alkali, we will be using an apparatus called burette, right? In burette, we will be adding alkali or base of unknown concentration, right? I'm just revising it because we have performed this experiment in our lab. This is just for the sake of revision. Similarly, in the conical flask, we will take acid of known concentration, right? We will be adding indicator in order to detect the color change, in order to detect the endpoint or the point of neutralization, right? So after opening the stopper, the base or alkali molecules will gradually fall into the acid and will react with acid to neutralize, to make salt and water. Now the concentration of acid is known, the volume of acid is known, right? And number of moles or acid is also known by the balanced chemical equation. So N is also known, right? Over here, we will be calculating volume of base by this experiment. Number of moles are known with the help of the balanced chemical equation, right? So we can easily find concentration by using the formula N is equal to C multiplied by V, or by merging both of the formulas, acid versus base or alkali. Acid has C multiplied by V divided by N. Let's say we are going to differentiate acid by 1, and base is having formula C2 multiplied by V2 divided by N2, right? So as number of moles are 1 1, we know the concentration of acid, we know the volume of acid taken, because we will have to take by, it depends upon us. We will have to take, for example, 100 ml, then we will be writing 100 ml over here, right? Similarly, volume has been determined with the help of this experiment. Number of moles is 1, and from rearranging this equation after putting values, we will be finding the concentration of base or alkali. Is it clear? So with the help of titration experiment, we can identify, we can perform the calculation to know the concentration of unknown solution, either it be base or it be an acid, right? So with the help of titration, it is generally used to calculate the concentration of unknown solution. I hope you have gotten clear concept. So acid base titration are one of the most important kind of titration. Clear, right? So these are just the guidelines that you are going to follow while calculating the concentration of unknown solution. For example, let's take a look at this one. Are you getting my points, right?
Yes, sir.
Now, again, we have sodium carbonate and dilute hydrochloric acid. That is, we have L, right, and sodium carbonate. They react together again to form sodium chloride and carbon dioxide and water, right? We are going to balance it to then say this 2. It's balanced now, right? Now we are going to take 25 cm cube of sodium carbonate. Sodium carbonate is 25 cm cube, right? After dividing it by 1000, it will become 0.025 dm cube. All right. We have also been given its concentration, that it is 0.05 moles per dm cube. This is the given data that question the examiner has given us, right? Now we have been given the volume of hydrochloric acid, dilute hydrochloric acid, and that is 20 cm cube. So after dividing it by 1000, it will become 0.20 dm cube. Clear? This is the concentration of acid. For example, we are going to take one over here. This is the concentration of alkali. This is the volume of, I'm really sorry about that, this is not the concentration, this is the volume. This is the volume of acid, right? This is the volume of base. This is the concentration of base, and we are going to find the concentration of acid in moles per dm cube. So we will have to calculate concentration of acid. Is it clear? Now I will again be performing two methods or two ways to find the solution, right? And both ways are correct. Remember, these are not steps, these are different ways. For example, method number 1 and method number 2. So look at method number 1. As this quick revision notes is following method number 1, so that's why first of all we are going to do method number 1, then we will be going to do method number 2. Again, they have converted. Let me clear this one, right? So we will be using mole ratio method in method number 1, right? For mole ratio method, we need number of moles of sodium carbonate and number of moles of hydrochloric acid. How? Let's find number of moles of sodium carbonate. We can say that let's find N2. We know the formula, N2 is equal to C2 multiplied by V2. So C2 is 0.050. Are you getting my point? Is your concept getting clear, right? Respond me, please. Respond me, dear students.
Yes, sir.
Is there any confusion? Volume is 0.025 dm cube. So we will be calculating this value, these values. Please calculate it down. Please hurry up. Hurry up. Is this the same answer, students?
Yes, sir.
Now in the second step, again we are going to find the ratio, molar ratio, right? Molar ratio of acid versus alkali. So as we know that according to the reaction, 2 moles of HCl will react with 1 mole to completely neutralize, right? So how many moles of base are given? 0.00125, right? X. So we are going to multiply it. 2 into 0.00125 is equal to, calculate it down please. Is it so? Is it clear, students? What we have done, we have found the number of moles of HCl, right? Moles of HCl. Now again, it means this is basically N1, right? This X is N1, the number of moles of HCl by molar ratio method. Then we are going to put the values over here in simple. We know that N1 is equal to C1 multiplied by V1, or C1 is equal to N1 divided by V1. So N1 we have just calculated, 0.025 divided by the volume was 0.020 dm cube. Now calculate it down please. Hurry up dear students, calculate it.
0.125.
All right, 0.125 moles per dm cube, right? So let me revise it again for you. The volume of acid was given. We will have to find the concentration of acid. The volume of base was given. Concentration was given, right? Now, finding the concentration of acid, we need number of moles of acid, right? We need number of moles of acid over here. So in order to find number of moles of acid, we will be using the mole ratio method. This is the mole ratio method. Remember, we have practiced a lot. So again, number of moles of base is equal to concentration into volume. We have calculated volume of, number of moles of base or alkali, Na2CO3, right? So as we know that according to the balanced chemical equation, 2 moles of acid reacts with 1 mole of base. So if we have been given 0.0125 moles of Na2CO3, then how much number of moles of HCl will be given? So we will have to calculate it. So we calculate the number of moles of acid, right? And then by putting in concentration formula for acid, we determine the concentration of acid. Now the method number 2 is simple little bit, like acid ratio base or alkali. Now wait. So C1 V1 divided by N1 is equal to C2 V2 divided by N2. Right? So just put the values. The concentration of acid is unknown. The volume of acid is 0.020 dm cube. Number of moles according to the equations are 2 is equal to concentration of sodium carbonate is 0.050. The volume of base is 0.025. This is mole per dm cube. This is dm cube, right? So divided by number of moles of base are 1, right? So we will be rearranging this equation like that. 0.050 moles per dm cube multiplied by 0.025 dm cube multiplied by 2 multiplied by 2 moles, right? Divided by 0.020 dm cube. Now please anyone calculate all these values and let me know about the answer, please. Amna, do you have calculator, please? Oh, sorry, Iman. Calculate it down. Are you here with us? Eza, Aliza, Iman, anybody?
0.125.
Alright, it is the same answer, right? 0.125 moles per dm cube. Clear? So these are the two methods. You will have to learn both of the methods. Should I revise it again or should I move towards our next numerical problem? No, look at this one. Can you do it for me, please? Or should I do it by myself? This is so simple, right? Because number of moles will be 1. HCl is 1 and NaOH is also 1, right? To form NaCl plus water. Alright, so we are going to solve it quickly. So now volume of acid is given, that is I'm directly converting it into dm cube, right? This is for example V1, right? And we will have to find the concentration of acid. Number of mole of acid is 1, and also whatever concentration of base or alkali, it's point. The volume of base is or alkali is point, what was that, 121, right? 121 dm cube, and its concentration is 0.100 moles per dm cube. Number of moles of base are also 1. Now again, by using the mole ratio, we will be first finding number of moles of base, right? So this is C2 into V2. C2 is 1 dm cube and volume is like that, and concentration is 0.100 moles per dm cube. So what will be the answer, please? Moles, right? Now L ratio NaOH, according to the balanced chemical equation, 1 mole needs 1 mole. So 1.21 10 to the power minus 3 will, of course, the number of moles will be same for acid, right? Then we are going to convert it into concentration. Concentration is equal to number of moles of acid divided by volume of acid. Number of moles are 10 to the power minus 3 moles, and volume is 0.025 dm cube. So its concentration will be, it's clear, Iza, Aliza, Iman?
Yes, sir.
Point
Yes,
zero
sir.
four eight four, 0.0484 moles per dmq. And also the second simplest method, you can do it pretty much easily, right? So what about this
That
one?
is
You'll have to learn both, right? You'll have to
okay.
do both. Both are necessary. Now, I will be sending you the worksheet number 12. You'll have to solve it.
Okay.
Right. Remember, you'll have to convert cm cube into dm cube. Now,